Hi everyone, it's Mrs. Griffin with the Unit 6 Lesson 6 video where we're going to be using trigonometry to find angles in our right triangles. In order to do that, we need to use what's called trigonometric inverses. So do make sure your calculator's in degree mode every time you do this by hitting your mode button, going down and highlighting degree and hitting enter, and then you'll be in degree mode. And then when we do these, like I said, we're going to use the inverse function. So the inverse of sine is written as sine with a -1 power, cosine with a -1 power, and tangent with a -1 power. On your calculator, you can see that they're in blue on mine here above the sine, cosine, and tangent because we use the second button to get to those. So always remember that those are the second functions. Okay, second thing we need to remember is our SOHCAHTOA because that helps us set up the correct fractions and decide which of these three ratios we will be using. So what we're going to do is we're going to identify where the angle is, and this angle is A, and this is the one we're looking for. This is our given angle. And then we're going to identify our opposite, adjacent, and hypotenuse. So remember, opposite is across from the given angle or the angle we're looking for. The hypotenuse is always across from your right angle. And the adjacent is the side that is next to both the given angle or one you're looking for and the right angle. And then we say which ones have values. So we have values on the hypotenuse and on the adjacent side. The opposite side has no value, and so we won't be using it. If you look at the SOHCAHTOA, sine requires use of the opposite, and since we don't have that, we can't use sine. So does tangent. It requires using opposite, and we also can't use tangent then. So what we're left with is cosine. And so what we do is we set it up by writing cosine of the angle, which we are looking for here, I'll call it A, is equal to the adjacent side, which is our 13, over the hypotenuse, which is our 20. Okay, now, the angle here is what we are looking for. Since we are trying to figure out what this equals, we need to isolate it. Anytime you're trying to solve for something, you need to get it alone. The way we do that is by separating it from cosine. You can't get rid of cosine by addition or subtraction because it's an operation. It's a function, much like a square root. If we wanted to figure out how to get rid of a square root that was on an x, we would square both sides of our equation so that those cancel because they're opposites. And if it was an x squared and we were trying to figure out what that was, we would square root because those are opposites. Well, cosine with a -1 and cosine are opposite functions. They are inverse operations. And so to get rid of a cosine, we have to use its inverse. So we will take the cosine -1, inverse cosine, of both sides of our function. So that means that the cosine -1 and cosine will cancel, leaving you with just the variable, the a that you're looking for. And then this is written as cosine with a -1 of 13 divided by 20, or 13 over 20. In the calculator now, we would hit second cosine, and a cosine -1 would come up, and then we would put 13 divided by 20 into the parentheses and hit enter. And we have 49.458, etc. This says to the nearest degree. So our angle A is approximately 49 degrees. Going on to number 2, again, we're referencing SOHCAHTOA. It helps us remember which parts of the triangle go with which trigonometric function and in what fraction. Okay, so first here is the angle we're looking for, B. This is the given angle, or the one we're looking for, and this is what we reference. So across from that is your opposite side. Across from your 90 is your hypotenuse. And next to the angle you're looking for and the 90 is your adjacent, and this one happens to be blank. So we don't want to use adjacent, we want to use opposite and hypotenuse. So if we can't use the adjacent, that means we can't use cosine or tangent because both of those require an A. Sine is the one that has opposite with hypotenuse. So we're going to write sine B equals our opposite value, which was 40, over our hypotenuse, which was 42. We're trying to get B alone, so we're going to do the sine inverse, or -1, on both sides, so that the sine will cancel and that the B will be left all by itself, will be isolated. And in our calculators, we will put the inverse sine of 40 over 42. And then this one also says to the nearest degree. So we're going to hit second sine, To get the -1, 40 divided by 42, and then hit enter. And it's about 72 degrees. Same thing with number 3. Here's the angle. Opposite of it is the 14. Opposite of the 90 is the hypotenuse. And next to both the given angle and the 90 is the adjacent. We cannot use the hypotenuse. So in SOHCAHTOA, we can't use any of the ones that have an h in them because the hypotenuse has no value. So we can't use sine or cosine. We have to use tangent. So tangent for the angle we're looking for is equal to the opposite over the adjacent. So the opposite is the 14 over the adjacent, which is the 29. In order to get c by itself, we need to get rid of tangent. We do that by doing the inverse. And whatever you do to one side of an equation, you always have to do to the other. And so c will be isolated, and it will be equal to the inverse tangent of 14 over 29. And we'll type that in by doing second tangent 14 divided by 29. And that's 25.76. So to the nearest hundredth of a degree, it'd be 0.77 because the 9 after it. So 25.77 degrees. Okay, same thing for the next one. Across from D is the opposite. Across from the 90 is the hypotenuse. Next to it is the adjacent. We actually have values on all 3 sides, so we can pick whichever one we prefer. I usually use sine just because it's the first one. So sine for my angle D is opposite over hypotenuse. So 68 over 85, or so. And then just like the others, we're going to do the inverse of sine on both sides. The sine and inverse sine on the left will cancel, and on the right we will have this to enter into our calculator, and to the nearest degree. Which would be approximately 53 degrees. And regardless of which function you used, as long as you set up the fraction using the correct numbers, you would be fine. Okay, now for 5, the angle is theta in here. Remember that that is the Greek letter theta, and a lot of times we use that in trigonometry. And we are going to be finding that angle. Across from it will be the opposite. Across from the 90 will be the hypotenuse, and next to both the angle and the 90 is the adjacent. So here we have to use the adjacent and the hypotenuse. Opposite is blank. So if you think about SOHCAHTOA, adjacent and hypotenuse is cosine. So cosine of theta equals the adjacent over the hypotenuse. In order to get theta by itself, we have to do the inverse of cosine on both sides. And we'll have cosine inverse of 12/13. And then we are going to round that to the nearest tenth. So you're going to hit second cosine, 12 divided by 13. And that would be 22.61, which is approximately 22.6 degrees. Number 6, we're looking for theta. Across from it would be the opposite. Across from the 90 would be the hypotenuse. And next to the 90 and the angle is the adjacent. Our opposite side is blank. So if you look at your SOHCAHTOA, we can't use anything that has opposite, no's. So that's no sine and no tangent. We're going to be using cosine again. So cosine for theta equals the adjacent, which is 6, over the hypotenuse, which is 9. And just like every other one here, we're going to get rid of the cosine by using the inverse. And theta will be equal to the inverse cosine of 6/9. And we'll enter it in the calculator, so to the nearest degree. Second cosine, 6 divided by 9. And you will get 48 degrees. Okay, for number 7, we're looking for angle X. Across from it is the 4, that's your opposite. The hypotenuse is blank, so we won't use it. Adjacent is next to both, so that's your tangent, TOA. So tangent for angle X is equal to 4/8. We're going to do the inverse tangent on both sides, which will be a tangent with a -1 exponent of 4/8, and then round that to the nearest tenth. So second tangent of 4 divided by 8 is about 26.6. Number 8, same idea. Here's the angle we're looking for, theta. The opposite is blank. The hypotenuse is 11, and the adjacent is 4.4. So since we're using adjacent and hypotenuse, that's cosine, ka. So we're putting the adjacent over the hypotenuse. We would do the inverse cosine of both sides, and then we would enter it into the calculator, and this one's to the nearest tenth. So second cosine, 4.4 divided by 11, and it's 66.4. Number 9, we're looking for theta. 4 is the opposite. The blank one's the hypotenuse, so we don't want to use it. And 13 is the adjacent, so this is tangent since it's O and A. So tangent for theta is opposite over adjacent. We're going to do inverse tangent on both sides. And then we're going to round this to the nearest 100th. So second tangent of 4/13. 14.10 or 17.10. And it does say hundredths, so you do need the spot even though it's a 0. And then x across from it is the 5, the 7 is the hypotenuse, the adjacent is blank, O and H is sine. So sine for x is opposite over hypotenuse, 5/7. We'll do the inverse sine on both sides, and then we'll type this in and it says to the nearest degree. So second sine, 5 divided by 7. 45.5, which would be 46 degrees. Okay, numbers 11 through 14 are actually set up even easier. All you have to do is, they already set it up, you just have to solve it. So to get A alone, we'll do the tangent -1, inverse of tangent on both sides. And that would look like this. And then we're just going to type it in exactly as a decimal instead of a fraction. And to the nearest degree, 2.0503 would be 63.9999, 64 degrees. So here we'll do the inverse cosine on both sides. And then you're just typing it in exactly like that. You have basically one less step to do. Sometimes that throws people. So second cosine, 0.1219, is 82.99, approximately 83 degrees. Okay, for this one we're getting rid of sine, so we're going to do the inverse of sine on both sides. $15.99 is approximately 16 degrees, and then the same thing here, we'll do cosine. This is beta. We're doing the inverse cosine of both sides to find beta. It would be about 55 degrees. 15, we have the same concept here. We're trying to find this angle. It's a word problem though. That doesn't change how we approach it. This is the opposite and the hypotenuse is blank. And this is the adjacent. So that would be tangent. Tangent of x equals the opposite over the adjacent. We're going to do the inverse tangent of both sides. And this says to the nearest degree. Which should be about 31 degrees. Okay, and then 16 is similar. We want to find the angle that this building has leaned. So basically we're creating a little triangle up at the top here. Okay, and finding this height, so the difference between the 47.1 and the 46.3. If you were to subtract that, you would get 0.8. So this side is 0.8. That would be our right angle. And the angle amount that it's leaning would be here, how much we would look up from the lowest to the highest. So essentially, we're dealing with this. So we have our opposite and our hypotenuse, that's sine. We would do inverse sine on both sides. and get 2.7.